Now let's look into volumes object. So volumes is a pretty important object. So to store the data and to have the persistence, the data persistence. So volumes must be attached with our container, with our container using pod. So on disk files in a container are ephemeral, which presents some problems for non-trivial applications when running in containers. One problem is the loss of files when a container crashes. So the kubelet restarts the container but with a clean state. That is the issue. That's the problem here. So the issue here is on disk files in a container are ephemeral, which presents some problems for non-trivial applications when running in containers. One problem is the loss of files when a container crashes because the kubelet restarts the container with a clean state. A second problem occurs when sharing files between containers running together in a pod. The Kubernetes volume abstraction solves both of these problems. So familiarity with pods is suggested. You should know that before we enter into this. So if you are not clear about what is pod and all those concepts, you just kindly watch this Kubernetes video from the beginning and get the complete exposure, and then you come here for this video that volumes. So then Docker has a concept of volumes, though it is somewhat looser and less managed. A Docker volume is a directory on disk or in another container. So Docker provides volume drivers, but the functionality is somewhat limited. Kubernetes supports many types of volumes. A pod can use any number of volumes, typically any number of volume types simultaneously. So ephemeral volume types have a lifetime of a pod, but persistent volumes, these are very important, but persistent volumes exist beyond the lifetime of a pod. That's what we want basically. We want volumes to be persistent beyond the lifetime of a pod. When a pod ceases to exist, Kubernetes destroys the ephemeral volumes. However, Kubernetes does not destroy the persistent volumes. For any kind of volume in a given pod, data is preserved across container restarts. At its core, a volume is a directory, possibly with some data in it, which is accessible to the containers in a pod. So how that directory comes to be, the medium that backs it and the contents of it are determined by the particular volume type used. To use a volume, specify the volumes to provide for the pod in .spec .volumes, that's inside the spec object of the YAML file, and declare where to mount these volumes into the container that you have to mention in the container section. And the container section, in the volume mount section, you have to provide this information. So now volumes cannot mount within other volumes, but also volume cannot contain a hard link to anything in a different volume. So now let's look into the types of volume or various types of volume that can connect with our Kubernetes. So Kubernetes supports several types of volume. AWS Elastic Block Store or AWS EBS CSI migration complete, Azure Disk CSI migration, and OpenStack CSI migration. Let me look into those from our documentation, Kubernetes documentation. This is volumes in background. Here there are different types of volumes from AWS Elastic Block Store, which has been deprecated, and here you can find out a configuration file, definition file for that, similar, but this time it's a pod itself, the pod. Then we have AWS EBS CSI migration, Azure 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 file, Cinder, OpenStack CSI migration, config map, the most important one, config map. Then we have FC, GCE persistent disk, that's a Google, GCE, Google Cloud Engine, and then we have more, that's GCE CSI migration, clusters, and this is what the host path. This is what we are gonna do. So this example we will do. So before that, let's cross check what all are there. There are a few more types. Local, NFS, persistent volume claim, and projected lot, a secret, vSphere CSI migration, a lot more. Yeah. So now we are going to do this one. So it's a host path. Volume mounts a file or a directory from the host node file system into your pod. This is not something that most pods will need, but it offers a powerful escape hatch for some applications. The most important, for example, some uses for host path are, if it is a Docker, we can use var lib docker. Inside that you will find the volumes. A running cAdvisor for a container, it's /sys, and some other thing will have that. And here we are going to use a MySQL one. So MySQL will have a /var lib MySQL, and this is the config file. This is the sample definition file for the volumes. So, and we have also attached an AWS Elastic Block Store sample file. So it consists of API version, kind, metadata. So there you have to give a test DB or test EBS Elastic Block Storage and spec. And inside that container information, there you have to mention the volume mounts. And then after that, the volumes as to be defined. Okay, let's get into the action. Okay, so it's basically we have seen so many options here. If you remember, we have gone through so many types of volumes. There are many options, and based on what project and what company you are working for, so they may use a storage solution. Your job will be to map that particular storage volume for to your Kubernetes volume. So we will do one example over here with host path, and the host path means the worker node directory, the worker node. So host path means which is on the worker node. We pick up a directory on the worker node and we map that as a volume to our pod. So let's look at the definition. Let's look at the definition file. But before that, let me create a directory mkdir voldef and cd voldef, and let me say vim. It's mysql pod.aml. But before that, let me write the similar file on here, and then we'll get back to that server or cops. So it's mysql pod.aml. So kind is obviously pod. Yeah, it's done. API version v1 kind pod metadata. I'm gonna say db pod. Then labels is not required, but if you want to have a label, you can attach the same db pod. And spec, we have our containers. So container, I'm gonna take image. So name MySQL, I'll give MySQL, and image, I'll get it from my Kuber Docker. Okay. Docker Hub. And I'll go with the MySQL. So I should have two versions. Yes, we have two version. I'll go with the v5.7. See all, and v5.7, and copy this, and image name here I'm gonna paste it. Yeah. So then let's attach the volume mounts. Let's remove this. So here I'm going to attach below the name. Okay. Yeah, here I'm going to attach the volume mounts. So volume mounts. Yes, we got it. Volume mounts. And so the first mount path. So mount path, I'm going to mention. So this is MySQL. I will take var lib MySQL. Okay, this is our mount path inside the container. Inside the container. So the name I'm gonna give as db vol. So now this is our mount path. This should be mapped with db vol, which is inside the host machine. So volumes. So let me attach the volumes. Volumes. Name of the volume, I'll say db vol. Then let me attach the host path also. So host path, I'll give it as a forward slash data or anything, whatever you require, you can give it. It's not an issue. Forward slash data and then the finally, so the port mapping we are not taking because it's not to be accessed. So then finally we'll have a type. I will go with directory or create. That's it. I think rest all absolutely fine. Host path, volume, DB volume, everything is okay. Let's see. Let's then let me paste it here. That's it. Our file is ready. So now let me do kubectl apply option F and MySQL pod.ml. So pod db pod has been created successfully. So now let me say kubectl get pod, and here is the db pod. It is on. So there is error, something is wrong with this. So let me check that. So for that what I have to do is kubectl describe pod and its db pod. Okay, the problem with the problem here is, so scheduled, this is no issue from the default scheduler, no problem. And kubelet a pulling image, also no issue, successfully pulled image. And created container MySQL, started container MySQL, and normal, so container image cube charen MySQL already present on a mission. So warning, back off, kubelet back off, restarting failed the container. Okay, so if you restart a container it failed, so that's what it's saying. So directory or create, let me reconfigure it. So kubectl apply option F, MySQL pod.ml, it's reconfigured, and kubectl get pod, and it's same, it's db pod. Here it's 35 seconds ago, it's pulled off completely. And so now let's so we have described the pod. Let's look into the describe again one more time. We'll describe the pod to find out the volumes, exactly how the volumes are connected. So let me scroll up. Yeah, here it is, you can see that. Yeah, mounts, this is not going to continuously run because this pod itself, it will start, and then after that if you try to start it again, it will not start because it's MySQL database. It's not a container to spin continuously. Okay, so here we have varlib MySQL from db wall. So these two things are mounted, and then host path is / a data, and host path type is directory or create. So host path, and this is how these mounts, these are volume mounts, and this is how they got mounted. So now let me delete the pod, kubectl delete pod, and then db pod. That's it, the db pod has been deleted. Now let me get back to the, that's it, this is how volumes work. However, we can have a much complex volumes, and every for every volume, every type of volume, we can clearly see that we can clearly see different types of various sample templates on our on Kubernetes documentation. You can see that various templates for various types of uh, volumes.